Welcome back to the BHT Machine Channel. In today's video, we will explore the production process of wind turbine towers, a crucial component in building sustainable, renewable energy sources. From the initial design, precise manufacturing, to assembly and quality control, every step is carried out with sophistication and modernity. Join BHT Machine as we uncover the cutting-edge technologies behind these remarkable structures. Let's get started. The infrastructure installation process for the Ahrensfeld-Wittefeld Wind Park marks a significant step in turning the vision of renewable energy into reality. First, the foundation construction is carried out meticulously and precisely. The foundation of each turbine is designed to withstand the immense weight of the tower, blades, and generator, while effectively dealing with vibrations caused by the wind. High-quality reinforced concrete structures, along with soil reinforcement measures, ensure absolute stability, regardless of weather conditions. This is the foundational factor for the safety and operational efficiency of the turbines throughout the project's lifespan. Next comes the underground cable system, the lifeline of the wind park. Each turbine is connected to the central substation through a network of modern underground cables, ensuring efficient electricity transmission and minimizing losses. The underground cable installation is done carefully, from trenching to protecting the cables with special material layers. This not only protects the cables from physical impacts, but also preserves the natural landscape and safeguards the area's ecosystem. In addition, specialized roads are built to facilitate the transportation of massive turbine components, such as blades over 50 meters long or towers weighing dozens of tons. The equipment storage areas are well organized to ensure the components remain undamaged before assembly. Meanwhile, the central substation, where energy is processed and transmitted to the national grid, is also designed with high precision to ensure stable and continuous operation. Most importantly, the construction team always prioritizes safety. From providing personal protective equipment to strict monitoring procedures, everything is aimed at ensuring the absolute safety of workers and equipment on site. Overall, the infrastructure installation phase not only creates a solid foundation for the wind park, but also demonstrates professionalism, environmental responsibility, and a commitment to sustainable development. This is a clear testament to the combination of advanced technology and modern development thinking, paving the way for a promising future in the renewable energy sector. Specialized roads have been constructed and renovated to meet the needs of transporting large components such as blades several meters long and turbine towers weighing tons. These roads must be able to withstand heavy loads and be suited for the transportation of oversized heavy equipment. To ensure safety and efficiency, the roads are built with appropriate width, slope, and load-bearing capacity, allowing transport trucks carrying equipment to move without encountering any obstacles. At each installation site, staging areas are established to store and protect essential turbine components such as blades, towers, and other auxiliary machinery. These areas are strategically located near installation positions to save transportation time and protect the equipment from weather conditions or potential damage. Protective measures are also applied, such as shielding or padding vulnerable parts, to ensure that the equipment remains in optimal condition before being installed. The turbine erection process is a critical step in constructing a wind farm, requiring close coordination between workers, engineers, and heavy machinery. Each component of the turbine, from the tower, blades, to the generator, is large and heavy, requiring assembly to be done carefully and precisely. Before starting the erection process, the large components of the turbine, such as the tower, blades, and generator, are thoroughly inspected for quality and completeness to ensure no parts are damaged during transportation. Auxiliary equipment, such as large cranes, assembly tools, and safety systems, are also checked to ensure readiness for installation. The first step in the erection process is assembling the tower, the main component of the wind turbine structure. The tower is usually divided into several sections, which are assembled in a bottom-up order. The sections are connected using large joints and bolts, and then a crane is used to lift each section to the required height and secure it in place. Using large cranes, high-capacity cranes capable of lifting weights up to several tons are used to raise the tower sections from the ground to the necessary height. These cranes can operate with 360-degree rotation to ensure flexibility during the assembly process. The use of large cranes ensures that heavy and bulky parts are transported and installed accurately without putting workers at risk. Securing and connecting. As each tower section is lifted, workers connect them using high-strength bolts and screws to ensure the parts of the tower are tightly linked and can support the weight of the remaining turbine components. The generator, or nacelle, is a crucial part of the wind turbine, housing key components such as the generator, gearbox, and control systems. The nacelle is installed at the top of the tower, where it will rotate to face the wind, optimizing the conversion of wind energy into electrical power. Before installing the nacelle, it is essential to ensure that the top of the tower is securely reinforced. Then, the nacelle is lifted using a large crane with a special cable system and auxiliary mechanisms. Lifting the nacelle requires high precision to avoid damaging the internal components of the generator. Once the nacelle is lifted into position, engineers begin the installation of the rotating mechanisms, ensuring the nacelle is securely fastened and can rotate smoothly to align with the wind direction. Workers then check all mechanical and electrical connections to ensure the nacelle functions properly. The blades of the wind turbine are among the most important components in the process of converting wind energy into electrical power. Installing the blades requires absolute precision, as the blades are extremely large and are mounted on a powerful rotor shaft. Before assembly, the blades undergo thorough inspection for quality and safety. The blade length typically ranges from 40 to 60 meters, depending on the turbine design. The blades are then lifted and attached to the rotor shaft of the nacelle. Large cranes handle the task of lifting each blade into position. The blades are securely fastened to the rotor shaft using robust mechanical connections, and all components are meticulously checked to ensure proper operation without any issues. Once the assembly is complete, a testing and commissioning process is carried out to ensure all components function as designed. Engineers and workers will inspect the electrical, mechanical, and control systems to verify that the turbine can operate stably and efficiently. This includes checking for proper alignment, functionality of the power generation system, and ensuring that all safety mechanisms are working correctly. The turbine is then gradually tested under real-world conditions to confirm its performance before it is fully operational. Wind power, a renewable energy source, is increasingly asserting its significant role in global sustainable development strategies. With its outstanding environmental protection benefits and unlimited renewability, wind power is becoming an attractive option for countries and regions looking to mitigate the effects of climate change and enhance energy security. However, to maximize the effectiveness of this energy source, it is crucial to understand the influencing factors, such as economic conditions, geographical locations, and the challenges compared to other energy sources. While wind power requires a relatively high initial investment, its operating and maintenance costs are much lower than traditional energy sources like coal or nuclear power. Wind power projects require investments in installing wind turbines, power transmission systems, and supporting infrastructure, which can create a significant financial burden in the early stages. However, the rapid development of technology in the wind energy sector has drastically reduced turbine costs, making wind power more economically viable than ever before. Unlike coal power, which requires continuous fuel consumption, wind power does not rely on fuel sources like coal or oil, helping to reduce long-term operational costs and minimizing dependence on non-renewable energy sources. Additionally, wind power can be combined with government subsidies and tax incentives, helping to alleviate the initial investment burden for investors and power companies. These supports play a crucial role in driving the development of renewable energy projects, especially in both developed and developing countries. Wind power, with its outstanding advantages in environmental protection, sustainability, and greenhouse gas emission reduction, is gradually replacing traditional energy sources like coal and nuclear power in many countries. Although the initial investment is high, wind power has low operational costs and does not rely on fuel, helping to mitigate market energy fluctuations. However, the development of wind power still depends on factors such as wind conditions, regional infrastructure, and government support. While wind power may not completely replace traditional energy sources, it will play a significant role in the global energy transition, contributing to a greener and more sustainable future. The development of wind power requires substantial investment, along with supporting policies and research to optimize the efficiency of harnessing this energy source, while also addressing environmental impacts and infrastructure connectivity issues.